they will not have to answer questions from students because there won't be any students.
Yeah.
It wasn't, they wouldn't have to block Facebook page. Nobody would be using it either.
I'll just save it here. Batch, but I actually took screenshots of this thing.
No, that's it. I think the recorder is up and should be recording from the right channel. Yep, it is. All right. Okay, so what I'm doing right now is I'm opening up base conversion and more operators. Not make it count for grade, but only as an exercise. Okay, so this way you guys can still kind of use it for practice purposes. So let me finish doing all the settings right first, and then you guys can go ahead and do it. So I will make it clear this one does not count for grade. Does not count for grade.
Is this a new
Change.
one or the one that's already been up there?
Sorry?
Is this a new one or the one that's already been up there?
Yeah, this is a duplicate of the one that is already up there.
Oh.
And I'm gonna turn off any restrictions so that you guys can do it anytime you want to. There we go. So that's the first one, and now do the same thing with more operators because you might find that one useful too. So we'll go ahead and do a duplicate here. And make changes to the duplicate. So this one is really only here so that you can redo it as many times as you want to, as a practice, as a way to understand the concepts and stuff like that. So we'll go to restrictions, remove restriction, save and return to course. All right. So both of those quote-unquote quizzes, basically they're more like homework assignments, are now reopened, but the new version does not account for grade, but it is still useful for the practice of preparing for the midterm. Which brings us to, guess what? The midterm. Well, before we get to the midterm, let me see if there are any questions regarding the homework assignment, find maximum. Some people have turned it in already, but I just want to make sure that everybody can get started with it. Okay, you can get a file, unzip it, get to the folder, get to the file, and you know where to insert your own code. Is that kind of okay? All right. So with this one, with that one out of the way, we'll go ahead and deal with the questions of the practice exam. Yep.
Sorry, I had a quick question.
Yep.
So, would you want us to find the maximum of negative numbers also, or is it just possible?
It doesn't matter, it's just the maximum. So if you're given numbers like -1, -5, -6, and -7, -1 is the maximum.
But we have to also make sure that it includes negatives, right?
It should work with negative numbers.
Okay.
To make it only work with non-negative numbers takes more work.
Oh, okay, then.
Yeah, comparing between numbers is already dealing with taking into account the sign of the numbers.
That makes
Yep.
sense. Okay, thank you.
Okay. So what we'll do today is what the bulk of today's lecture is going to be on the practice exam questions. For those of you who have taken classes from me already, you know that when we have a practice exam, like a mock exam, the actual exam is 1 week from the practice exam. So that means next Monday we will have our first midterm. And the time is going to be the same as the lecture. So we'll start the exam at exactly 1:15, and the exam will end at exactly 2:30. Okay, so that will be the time frame. The exam is going to be open book and open notes. Okay, because the previous class there were too many students and we didn't have enough computers for everyone. So it's going to be paper-based, and if I make one exam paper-based, I'm going to make the other exam paper-based too, because I don't want one to be online and the other one to be paper-based. That means I have to prepare it twice. So that's my current decision, is to make it a paper-based exam. If it is a paper-based exam, then all the notes, everything that you want to bring in to help you will also be paper-based. Just so that the two sections of the classes are basically the same. Okay. So even though we do have computers here and everybody has a computer in front of you, we still have to be completely paper-based. Are there any questions about what you can bring and what you cannot bring to the exam? It's still open. I mean, you can print out everything that we have done so far. You can go to the reference website and print out pages from there as well. Okay, so bring anything that is either printed or handwritten prior to the test, and that can be used during the test. I can supply calculators if you do not want to bring a calculator that may or may not be okay. I don't want people to use their cell phones. So what I'll do usually is I will bring in like a whole big bag full of Dollar Tree calculators. $1 each. I forgot to buy a whole bunch of scientific calculators this year, so I'm gonna have to wait until next year to do it. But even scientific calculators at the Dollar Tree is $1. Yep, exactly. So I kind of missed that window this year, but I will provide calculators in case anyone needs it. These mock questions are here just so that you know what kind of question I will be asking and the scope of the questions. The actual question obviously won't be exactly the same. They will be kind of like a modified version of this kind of question here. This is question number 1. So you're given a particular program or a part of a program. So from here to here, we have a part of a program. This part here, this is actually line 10, but it only shows a 0 in Chrome. If you use Firefox, it actually shows 10. So the interpretation of some cascading style sheet styles is not correct in Chrome for whatever reason. So you have to answer the question, first, by saying, if you think this code has a syntax error, and you can assume that X, Y, Z, and K, they are all declared as integers already by the time we get to this code. You want to, if that is what you think, you have to say why there is a syntax error, and if so, how do we fix the syntax error? So the first thing you need to do is to analyze this code and see if there is a syntax error or not. All right? Yep, go ahead. There's actually no syntax error with this code. This code is actually okay. So what we'll do now is to analyze this code, but we'll kind of look at this program like what a compiler would. Okay. When a compiler encounters the first word of this program, it can see that, oh, this is the beginning of a conditional statement. Okay. So as soon as the compiler understands, oh, this is the beginning of a conditional statement, it automatically comes up with expectations. Okay. So it will be expecting open parenthesis, an expression, close parenthesis, and a statement as the then branch of the conditional statement. Optionally, it can also see an else keyword and a statement for the else branch of this conditional statement. So that's what the compiler is thinking at this point, is to say, okay, I can expect all of these things, some optional, to be following this particular keyword if. Are we doing okay so far with this? It is not unlike when you see open parentheses when you're in a math class or any type of class that has expressions or equations. You will think, oh, I am expecting a close parenthesis at some point. Is that analogy working? Okay, when you see open parentheses in an expression, you know that you should be expecting a close parenthesis. So in this case, it's kind of the same thing. When you see the word if, you're expecting certain things to follow the if keyword here. We have open parentheses here, we have an expression, and we have a closed parenthesis. So it is good up to this point. Yep.
And that closed parentheses is why we don't need a semicolon after that, because it's already stating that it's the end of the expression.
A semicolon is only needed to turn an expression into an expression statement. So at this point, right now, as soon as I have seen the closed parenthesis, the one that I have highlighted, the compiler is now saying, okay, now I'm expecting a statement. Okay, so when it's expecting a statement, what does it see? What is the word right after the closed parenthesis? It's if, which is perfectly okay. Okay, so the compiler says, okay, the then branch all by itself is another conditional statement. This is almost the same thing as seeing an open parenthesis inside, a open parenthesis after a open parenthesis, which is perfectly okay, right? You can have nested parentheses, and as a result, you can also have nested statements like this. Okay. So the compiler sees this particular if word, then it will also expect a open parenthesis, a expression as the condition, and a close parenthesis. And then it's saying, okay, now I expect one single statement after this as the then statement. And it sees this expression here. K equals to 1 is an expression, which is not a statement. But fortunately, it also has a semicolon after that, which will turn this entire line into an expression statement, which is a very simple statement, but nonetheless, it is a statement. It satisfies the requirement that if needs a statement after the expression. Is that okay so far? So this is the then branch of this particular conditional statement. But after this statement, we also encounter the optional keyword, which is else. Now, as soon as the compiler sees the word else, it says, okay, now the statement after else is no longer optional. Because as soon as I see else as a keyword, I now need to expect the branch, okay, the statement corresponding to else, which is fine because now it sees k equals 2 as the statement with a semicolon, as a statement after else. So by the time it sees this particular semicolon, it is now done parsing the inner conditional statement, because this semicolon is ending the else branch of this conditional statement, and hence, this entire conditional statement is recognized and say, okay, this is one single statement corresponding to the then of this if here. Yep.
What if you had, for line 4, another expression statement and then an else? Wouldn't it just basically not know how to finish?
That would be a syntax error.
Okay.
Yep. In other words, if you insert like k equals 3 semicolon between line 3 and 4, that will generate a syntax error because it cannot possibly expect an else at that point. Yep. So the compiler would stop basically right there and say, okay, we have a problem. But in this case, we don't have that. We have a single statement corresponding to the then branch of the inner conditional statement. So now the compiler sees this else here. Okay, is the compiler going to be confused, or does it know whose else we are talking about?
Yeah, it goes back to line 1.
Exactly. This else corresponds to the if of line 1. Okay, which is okay. But as soon as the compiler sees this else and say, okay, I have seen the word else, I'm now expecting the statement corresponding to this else, it now wants to expect a single statement. But what it sees is an if here, which is okay, because that means, the else branch corresponding to line 1 is a conditional statement all by itself. So now we just have to parse this conditional statement starting on line 7. It has an open parenthesis as an expression, as a closed parenthesis. So everything is working out so far. It has to have one single statement corresponding to the then branch of the conditional statement, and then followed by optionally an else keyword. Since it is here, it is also expecting a single statement after else to be the else branch of the inner conditional statement starting on line 7. So by the time we parse this particular semicolon, it is not only ending this conditional statement here, but it is also ending the other conditional statement. Because from line 7 to line 10, that conditional statement is the one single statement corresponding to the else on line 6. So by the time that statement concludes, it also concludes the statement starting on line 1. So at this time we can say, okay, the entire thing is parsed and the structure is understood. Are we kind of doing okay so far with this? So the one way you can kind of help to kind of understand how the compiler does everything is to kind of do this. I'm not sure whether this helps you or not, but you can do something like this. Is when the compiler sees if, you kind of fill in what it is supposed to see after that. Okay, so you say after the if, we are supposed to see open parenthesis, some kind of expression here, close parenthesis, a then statement, okay, then statement, and then after that, optionally, using bracket means optional. Optionally, we have the word else, and then also optionally is an else statement, like so. Then you fill in and say, okay, since we're expecting open parenthesis here. Do we see it? Yes, we do. We are expecting an expression here. What do we see here? We see x is less than y. We are expecting a close parenthesis here. What do we see? We see a close parenthesis. We are expecting to see a statement here. What do we see? We see if here. So now you say, okay, the then statement is another if statement. So as soon as you see an if here, you do exactly the same thing. If some kind of expression, and then else, optionally, another else part, another else statement.
You need a then after the first statement.
Right, you need a then statement here. Thank you. Okay, and then you continue the parsing and say, okay, I'm expecting an open parenthesis. Do we see an open parenthesis? Yes. I'm expecting a statement. Do we see a statement? Yes. What statement is it? Excuse me, what expression is it? Y is less than z. Now we need to see a then statement. What do we see? We see k equals to 1 semicolon. That is a statement. Okay, it is one single statement. So now we say, okay, that is k equals to 1 semicolon. Now optionally, we can see else. Do we see else? Yes, we do. So that means this part is not optional here. It is already, I know that we're expecting else here. So we see the else keyword, but after that we need to see else statement. What do we see? We see the statement here, which is an else statement, k equals to 2. So now we say k equals to 2 semicolon. Now the semicolon is very important in this case because without a semicolon, it is just an expression and not an expression statement, which would not fit this requirement. Okay? So that's how, one thing you can do to kind of analyze the syntax of a particular program or code and find out, whether it is syntactically correct or not. Does everybody kind of get an idea of, what to do to analyze the structure of your code? Sort of? Okay. All right. So with that part out of the way, the answer to this particular question is nope, there is no syntax error with this code. So you can skip this part here because there's no syntax error to state, and you don't have to tell me how to fix it because there's no problem. If there's no problem, you go to the else part of the question, and you have to indicate the lines in the order of their execution when this code runs for each of the following test cases. So each one is a test case. This is a test case, assuming x equals to 2, y equals to 3, and z equals to 4, which lines will execute in what order? Okay? And then the second test case is completely independent from the first one, which is assuming x equals to 2, y equals to 2, and z equals to -2, what lines will execute in this program.
How do you show your work for this?
You just give me the line numbers. So basically, for that part of the question, you have to start with line 1. This is a conditional statement. You have to start with line 1, right?
Okay, so let's say your x is less than, let's see, 4. So for line 1, would you put true on there?
No, you just have to show me the line numbers. So for this particular test case where x equals 2, y equals 3, and z equals 4, line 1 has to execute. But what do you do after line 1? Where do you go?
Line 2.
You go to line 2. And then after line 2 executes, is y less than z true or not?
True.
It is true. So which line do we go next?
3.
Line 3. And then which line do we go next?
10.
Not 10. If you say 10, that means that k ends up with a value of 4. That's it. Line 1, 2, and 3. That's it. Okay. Now, if you want to emphasize we are done here, you can optionally indicate the next line is whatever is after line 10. I mean, that would be fine too.
So that's what you're looking for, just which lines execute and
Yep.
whatever? Okay.
Yep. Just the line numbers in the order that you get to those lines. Yep. Are there any questions about this part of question 1? It's a lot easier than tracing in the other class.
Yeah, I feel like you're tricking us or something.
Oh, no.
Are you sure?
Okay, what about the second test case? The second test case is x equals 2, y equals 2, z equals to -2. So let's, which line do we start with?
1.
We start with line 1, and then where do we go? X equals y is false. So we have to go to
7.
line 6 or 7. Now, for people who took my class before, technically we go to line 7 right away. But since there are people here who had not taken that class from me, so we'll say line 7. Line 7 has to be here, but line 6 is optional. If someone says line 6, I'm not going to take any points off. Okay. On line 7, x equals to y is true. So where do we go next?
8.
Line 8. And then after line 8, where do we go?
And
After 10. So we're done. Okay. So whatever is after line 10, or you can just end with line 8. That would be perfectly okay as well. So that's what I'm looking for. When I ask you guys to show me which line will execute in which order. Now with a loop, it's a little bit more tricky. Okay, with a loop, because you have to go back and redo things again and again. But there's a second part to this part as well. There's a second subpart, if you will. So the second part says, not knowing the exact values of variables x, y, and z, indicate as completely as possible how the variables relate to each other. If code execution reaches each of the following line, consider each one as an independent test case. So what this means is, if I ever get to line 3, okay, what does it mean? What can I say about the values of x, y, and z and how they relate to each other? That's what I'm asking.
x is less than y and y is less than z.
Yep. So if I ever go to line 3 here, it means, I have this condition has to be true, but in order for me to even evaluate line 2, it also means this condition has to be true as well. So the answer to line 3 is x is less than y is true, y is less than z is true. There's no need to infer that x is less than z. Okay, in this class, I don't need you guys to give me all the inference. You just need to tell me the basic stuff. Okay, there's no need to simplify either. If I get to line 5, what does it mean?
X is less than y, y is greater than z.
Y is greater than or equal to z. Or you can just say it is not the case that x is less than, y is less than z.
Y is less than z is false. Did you say that?
Yep. You can say that as well. And so all of those are equivalent except for y is greater than z, because equal to is actually a part of it too.
Okay.
Yep. Now, I will do the same thing as with the other class. I'm going to use App Inventor to kind of show you the structure of that particular statement. So this structure here, not counting when button do it is clicked, this structure here reflects the structure of the C code here. No, not here, this. Yep.
So if you put y is greater than or equal to z, that's wrong?
If you put y is greater than or equal to z, it is correct. If you
Okay.
say y is greater than z, then it's only partially correct. Because equal to is a possibility. How about for this line here? If I ever get to line 8, what can I say about the variables x, y, z?
X is greater than
X equals y,
It's not less than y.
and x is less than y is false.
Or y, x is equal to y.
That's a well, x is equal to y, yeah. what you said.
Okay, if we get to line 8, the condition of line 1 has to be false, right? So that means x is less than y has to be false. That means we get to line 7, but since we are on line 8 at this point, so that means the condition of line 7 has to be true. So that means x equals to y has to be true. We cannot relate either variable to z in this case because there's nothing to confirm anything between x and z or y and z. Yep.
Would we be missing a step if we had just said that x has to equal y?
You can simplify, if that's okay.
Because we're inferring that.
Yeah, it is inferred. So you brought up a really good point, because when you say x is greater than or equal to y and x equals to y, you can just simplify the whole thing and say that x equals to y. Because when you're with a conjunction and one expression includes the other one, the one that is more restricted is the simplified version. You can just say that instead of saying the whole thing.
Yeah, because the first one has to be true. So the second one.
Correct. in this case, x equals y being true implies this is true. Yep. It's the other way around.
Okay.
Yep. You can say that this one here, you can say it is not the case that x is less than y, is implied by x equals to y. So that is another way to say that. Yep. And then the last one, if I ever get to line 10, it means
X
means
is
what?
greater than y.
If we get to line 10, it means x is less than y has to be false for me to get to the else branch of the outer conditional statement. But in the inner conditional statement, x equals y also has to be false. And there's another way to simplify this. What is the simplified version of this?
X is greater than y.
X is actually greater than y, because if x is not less than y and x does not equal to y, the only possibility left is x is greater than y. In the test, yep, go ahead.
The explanation point's the not, right?
It's not equal.
Yeah, that in C it is logical not. Yep. So in this class, I only use the C notation. Instead of using the little cliff symbol for negation, that's all I'm going to use. Because in your code, you're going to have to use the same symbols. All right. Are there any questions about this particular one? No questions? Now, how do you know that what I said is true? Everything. You can just run it, right? Copy and paste this code into a program, put a main function around it, declare the variables, x, y, z, and k, and then use the debugger to help you debug the program. Okay. Yep.
Do we have to phrase it exactly like we did, saying it does not, or is not, x is not less than y, or could you say x is greater than y, and that's why we get to line B?
Okay.
Because they're the same thing.
Not x is less than y is not the same thing as x is greater than y. It is x is greater than or equal to y.
Okay.
Yeah, don't forget the equal to, because the equal to is important.
Okay.
Yeah, I would use this, I would not do any derivation, because this is counted as 100% correct already. If you do any extra work to optimize it or to make it look better, and that turned out to be incorrect, then you're forcing my hand, right? You're forcing my hand to go like, no, that is not correct, right? But if you just give me this, I have no reason not to give you all the points, because that's all I'm looking for. Yep. So don't do any extra work unless you are 100% confident
What was the
about the
extra work?
conversion step.
What was the extra work you said we would have messed up?
Any type of simplification, like
Oh, okay.
converting a not x is less than y to x is greater than or equal to y, or to simplify this entire thing, the conjunction, the entire thing, into x is greater than y, that is extra work. If you show me only the result of the extra work, but not how you derive from the original work, then I cannot even give you any points. So I would just kind of stick with the original form and just say, okay, this is the most elemental form of the answer. Any questions about what I'm expecting as the answer? Now, for those of you who are not comfortable with exclamation point being not logical not and ampersand meaning conjunction, for this test you can still spell out not and okay, but it's not going to be very helpful, because in your homework assignments you will still have to learn the syntax of C and C++. So I strongly encourage everyone to start to use the C notation instead of spelling out the words. All right, any questions about this one? No questions about this one? All right. Let's move on to the next one then. This is the second one. I like this one. I really, really like this one. What is the effect of the following expression? This is one long expression. I mean, it is an expression, okay? It's just an expression with a sub-expression and a sub-sub-expression. That's what it is. Because this is an operator, this is an expression, this is an operator, this is a longer expression, this is an operator, and this is yet another expression. So you can look at the whole thing as an expression. Yep.
Is that the bitwise not symbol?
This is a bitwise exclusive OR.
Oh, that's right.
Yeah, the
Okay.
bitwise not is a tilde symbol, and then this one is a exclusive OR.
So 1, 1, 0.
1, 1 is a 0, 0, 0 is a 0, 1, 0 is a 1, 0, 1 is a 1. Yep. And remember, it is open book and open notes, so you can't print out anything that you find helpful, with you. My personal recommendation is when you study, jot down on a separate piece of paper as your quote-unquote cheat sheet to bring in, because that's going to be a summary of everything that is important to you, and because you wrote it, you know where it is. As opposed to my notes, it may not be organized the way that you think things will be organized, so it might be harder for you to spot things. But you can bring anything that is printed or handwritten prior to the test. That's okay. You can even use 20 gazillion little post-its, of all kinds of different colors to help you locate, all the green tabs, correspond to control structure, all the blue tabs correspond to expressions, all the yellow tabs correspond to tricky stuff that talk about in class, and then all the pink tabs correspond to sample code that we went over in class. I mean, you can take screenshots of the YouTube videos. Just freeze frame, select, do a print screen, and then just print it out. I mean, that's fine with me too. Do whatever you think is going to help you, to prepare for the test. I think for people who went through the whole gyration to do all that stuff, in the end, they won't need what they actually bring into the class. Because in the process of getting ready, you're already done. You won't need it anymore. It's kind of like Dumbo's, feather. Dumbo and the feather.
Oh, the elephant.
The elephant, yeah. Yep. You never needed it to begin with. All right, so let's take a look at this one. This one looks kind of interesting. So let's find out what it's supposed to do. Now, if I just give you this code here and say, describe what it does, it's going to be a little bit more difficult, okay? So instead, I'm giving you a specific values, one for x and one for y. So now you can tell me the end values of x and y after this expression is evaluated. But my question is not just that. I want you to show me step by step what is the value of each expression. And if each expression, or if one expression has a side effect, if it changes the value of a variable, tell me which variable is changed to what when that operator is evaluated. Okay, so it has to be completely step by step. So let's go ahead and approach this one and find out how to do it. And also, for simplicity, assume the variables are 4-bit integers, because if you use 32-bit and you have a bit exclusive OR operator, you can end up writing a lot of zeros and a lot of ones. So to save you the time of writing all the unnecessary zeros and ones, we'll deal with 4-bit integers. So you only have like 4 zeros and ones to deal with at any particular time. All right, so let's see how we can approach this problem here. So let me just kind of write the expression first. And then we'll go ahead and do it. So as far as I'm concerned, the first thing I'm going to do is to start with the innermost portion, which makes sense, right? Anytime you have a nested expression that has a lot of levels of parentheses, you always start with the innermost part, and then you work your way out, which is exactly what I'm doing here. And I'm going to change this to a way that is easier to understand, because x caret equal to x, y caret equals to x is the same thing as y equals to y caret x. Okay, that's just a shorthand of the other one. Okay, and caret means exclusive OR, bitwise exclusive OR. Do we know the current value of y at this point? This is at the very beginning of the whole process. Y has a value of 5, but since exclusive OR, bitwise exclusive OR is only easy to visualize when we're dealing with binary numbers, what is the binary representation of 5?
0, 1, 0, 1.
0101 as a 4-bit number, so that first 0 is kind of important. So we say 0101, and what is the value of x to begin with as a binary number?
0100.
0100. Very good. So now we can perform the actual bitwise operation. 0 bitwise exclusive OR 0 is
0.
0. We have a 1 versus a 1 here. The
Zero.
result is a 0. 0 versus 0.
0.
Give me a 0. 1 versus 0.
1.
Give me 1. Okay? So the end result is the expression value of expression is 0001, and as a side effect, y is updated to 0001. That
Can we just say equals 1, or do you want to leave it like that?
I would just kind of keep it in a binary format because you will use it again later in the next step. Okay. You don't have to use exactly these words, but you do have to indicate both of these things. What is the value of the expression itself? Because we will use the expression, the value of the expression in the next operation. So that's why that's important. But you also have to tell me how y is updated. If y is updated, you have to tell me how it's updated because that's going to be used later. So all of those things you have to document it and show me. So now we are ready for the next expression here, which is x bitwise exclusive NOT with 0001. This 0001 here does not come from y, it comes from the value of the expression. Okay, which is also put into y because of the assignment operation. Okay. So the first thing we do is to convert this back into the more easy to understand form. And then we ask, what is the value of x at this point?
4.
It is still 4, right? Because nobody has changed the value of x up to this point. So 4 is 0100, exclusive OR with 10001. So now we just have to look at each bit position and perform the bitwise exclusive OR operation. 0, 0 is 0. 1 versus 0 is 1. 0 versus 0 is
0.
0. 0 versus 1 is 1. Okay, very good. So now we are done with this one. We say the value of this expression is 0101, and then x is also updated to 0101 as a result. Yeah, exactly. So now we are all the way to the outside. So now we have y exclusive OR with 0101. And then we first convert it to y equals to y bitwise exclusive OR with 0101. And this is the tricky part. Of the entire calculation, this is the trickiest part. What is the value of y at this point?
0001.
0001, because we updated it in the first step. So you have to remember to use the updated value of y at this point, because this is actually the third operation. In the first operation, we changed it already. Okay, so y is now 0001, and then we use a bitwise exclusive OR with 0101. So we basically just look up the table for exclusive OR. 0, 0, give me a 0. 0, 1 gives me a 1. 0, 0 gives me a 0. 1, 1 gives me a 0. So as the result of this, we still have to say this overall expression gives me 0, 1, 0, 0. And then y is updated again the second time to 0, 1, 0, 0. So if you are to describe overall what we are really doing with the variables x and y, we just swap the values. We exchange the values of x and y.
And the bitwise exclusive OR, it doesn't matter. I mean, I'm not saying we should do it on the test, but it doesn't matter if we swapped like x and y in terms of orientation, because it's still going to be the same.
It is commutative, so it's just like addition. If you swap the two sides, it doesn't matter. Okay, are there any questions about this one? What I'm expecting as a part of the answer and how to work on it?
So are you just really looking for y is updated to 0, 1, 0, 0, and then all the work in between?
Yep. But as a part of it, I would spell out all the calculations. Like, I personally would change the form to this form first, just so that I know what are the values that I'm operating with. Because without this form, it's pretty hard to write it out like this. And if I don't write it out like this, it's hard for me to get to the answer.
And you aren't necessarily going to use the bitwise exclusive OR. It could be any operator, right?
It can be any operator. Any operator that we have talked about. Yep. But not every single operator can use the compound assignment form. The logical operators, for instance, cannot use this form. There's no operator like ampersand equal to. That does not exist.
Did you want the answer to stay in binary?
Yeah, it's kind of understood that it's binary, because it's all zeros and ones, and there are 4-bit positions, so that would be fine. Right. Any other questions? Ooh, I just thought about what to ask in the actual final, exam question. And of course, if I don't write it down, I'm gonna forget it. So can I ask you guys to remember for me?
Oh.
Absolutely.
You're so trusting.
Absolutely.
Absolutely.
I'll write it down for you right now.
And you're extremely funny.
Don't forget the key too, right? Not just the question.
You told us to remind you to give us the key to the answers for the midterm.
Yeah.
So when you do the
Okay, this is the third question of the mock exam. So with this one, I actually personally look at this one as one of the easier questions. The other two, kind of tricky in some ways. But this one, I think is not too tricky. So with this one, I want you to analyze the following code. Show how variable x is updated. So each time you update variable x, use a new row to tell me how the value of variable x is updated. That's all I'm asking, okay? So you basically have to track this program down in your mind or on a piece of paper, and then tell me how x is getting updated, okay? I don't really care about the cases where I is updated in the final answer, but how you update I actually has a lot of impact to how x is going to be updated, okay? So there's a little bit trick to it, but not too tricky. Okay, so we'll start with this one, over here. The first change to x is on line 1, x gets updated to 0. That's the initialization. Because before this initialization, x can be any value, right? So this is the first update. After this update, nothing happens, okay? Because I has a value of 0. I compare 0 to 3, and then I add 1 to I. That's what post increment is about. You use the value before the increment as the value of the expression, okay? So the effect of adding 1 to I happens after you utilize the value of the expression. So in this case, I'm actually comparing 0 to 3, even though we end up adding 1 to I and I becomes 1 after the expression is evaluated. 0 is less than 3 is true, so we perform the body of the loop. So we get x plus equal to 1. I is already 1 by the time we get here. So in your note here, when you answer this question, you have to say x becomes 0, which is x plus 1, which is 1. Okay? If you skip this part here, that's okay. As long as you tell me x is 1, it's okay. After this, we perform this operation, right? This is called a post operation of a for loop. So we add 1 to I, and in this case, whether it is pre-increment or post-increment really doesn't matter, because nobody cares about the result of the expression, okay? It is only the side effect of adding 1 to I that we need to track. Okay? So after this, I becomes 2. After the post operation, we re-evaluate the condition. So at this point, I'm comparing 2 to 3. 2 is less than 3 is true. Okay, remember it's a post operation. So once we get 2 is less than 3 is true, then I becomes 3. Okay, so that means we will get to this point because 2 is less than 3, But by the time we get to line 3, I already has a value of
3.
3. Exactly. So in your note here, you have to say, if I track everything, this is how I would track it. Just to remind myself, how I get the answer of 4. So x becomes 4 at this point on line 3, and then it will go back to this step here. So I becomes 4 at this point, and then it goes back to this step. 4 is less than 3 is false. We get out of the loop. So when we do get out of the loop, if there is a line 5, what is the value of I on line 5?
4.
It'll be 5 already. Okay. Even though we use 4 to compare to 3, the increment is a post increment. So that means after the comparison, I actually gets a value of 5. So by the time we exit the loop, I ends up with a value of 5. Right? Any question about this one?
So that would be like, we just said I is less than, the way to think of it would be I is less than 3, comma, I gets I plus 1, maybe like in that, just as a way of like the operation that it goes.
You
Say
said
it
that,
again.
like that condition does 2 operations. It checks.
The condition has 2 operations, yes. So if you want to look at this expression here, it's kind of hard to express it without the post increment because the increment happens after the comparison, basically.
Well, that's what I'm saying, like I is less than 3, comma, I gets I.
No, because if you use a comma, the second expression becomes the value of the overall comma expression. Okay, let me show you what I mean by that. So if you say that this is, okay, if you look at this expression, it's not the same thing as this. In fact, this one is always considered true. Well, it will be considered true for a long time, okay? Because I is initialized to 0 to begin with. So 0 is less than 3 is true, but I tossed it away. It is as if this expression was never even here because even though it returns a non-zero value, I immediately threw that away. And then I evaluate the second expression. So with the second expression, since I started off with a value of 0, 0 plus 1 is 1, I put the 1 back into I, and that 1 becomes the result of the second expression. Now the second expression is the last one of the comma separated expression, so that becomes the overall value of this entire expression. 1 is non-zero, it is true, right? And then 2 is true, or I should say 3 is true, and so on. So it will stay true for a long time before we wrap around back to negative numbers and then work our way back. And even so, it may not get back to 0 ever.
Wouldn't you run out of memory? You might run out of memory first?
Well, in this case, it won't run out of memory, but it will never get back to 0. Because we have 2 increments.
Oh.
So it will only go to odd numbers. So you go from 1 to 3 to 5 to 7, but when it does wrap around, it will be the odd numbers. So you eventually get to -1 and then back to 1 again. It will never be 0, and if the expression is never 0, it's always non-zero, which means the loop will never get out. But to answer your question, the original question, there's no easy way to express this.
Okay.
Yep.
You want us to put the ending value of I in the answer?
No, in this particular case, I only ask about x. But that makes it even more tricky because by not asking you to track the value of I, some people may think, oh, it's not important to really pay attention to I. But in the end, it is tracking the value of I that can either make or break this program. The value of x is easy to track because this is the only place that I make any changes to x. And it's nothing that is tricky at all. I is the tricky one because it has a post increment here as a part of determining when to get out of the loop, and then has a pre-increment here at the end of each iteration. So even though I did not ask you to track the value of I, you have to do it correctly to answer this question. Yep.
When we were just talking about the comma separated expression, would there ever be like an actual real world use to have that as a conditional statement?
The use of a comma separated expression is to stick multiple operations into one single thing where a single value is expected. So it's a trick to kind of put more code into a place where it is only expecting one thing.
Okay, so it's like curly braces for expressions? Like how curly braces help you
Yeah,
with
kind of. It's a composite, right? It just makes a composite. Okay, since you guys asked these questions, let me give you a case here to see if you know what the answer is. Okay, so I'm gonna give you this 1, 2, 3, 4, 5, 6. Okay, there we go. Okay, what is the overall? Oops. What is the overall value of this expression?
6.
6. That's it. The last one, right? Nothing matters except for the last expression.
It's not really doing anything, is it?
It doesn't do a single thing.
I was like,
It doesn't do a single thing, and yet in C it is a valid expression.
okay then.
What about this one?
4.
It's just 5. It's just 5 itself, because in the outermost layer we have 1, 2, but in 1, 2, 2 is the last one. So that means this expression as a whole, 2 is the value, 3 is the value here, and then this is a list itself, or this is a comma separated expression itself. So we look inside, 4, okay, fine, but we toss it away, and it is actually 5. So 5 is the value of this expression, but since this is the last expression of the outer comma separated expression, that means 5 is also the overall result of the entire expression.
So how would, if we ran that in a compiler, what would the compiler say after that line executes?
This is an expression. It can only go where an expression is expected. So if you use a printf, you can stick this in as the value that you're printing, and it will print 5. You guys are looking at me like, I don't think so. Well, let's do it. I mean, that's really the practice makes perfect. I mean, really do this as frequently as we need to, right? Okay, so we'll say comma.cpp. I mean, there are many ways to test this. I mean, you can use a GDB and put it into a variable, and you can check the values of the variable after that. Yep.
You don't have to do it. You can do it this way. But could you echo that and say the C shell?
Yes. Well, maybe. I don't know whether C shell has bash has the same evaluation. I think it has, but since this is a C and C++ class, we'll do it this way. Okay, what was it again? 1, 2, 3,
3 in the middle.
and then
Nice.
4, 5.
Guess it
Oh,
really
3
doesn't
is in the
matter.
middle. There we go. Okay, there we go.
There's too many.
Hmm?
Too many.
No, it's good. I like VI because of this. You put, the green cursor is where the actual cursor
Oh, yeah,
is.
okay, there it
The
is.
blue cursor is just, saying, okay, since you're on a closed parenthesis, this is the beginning. This is the open corresponding to the close that you're on right now. So it's a very easy way to catch, like too many parentheses, too many open, too many close. Easy to spot. Okay. And there's a way to jump too. If you do a open square bracket, and the parentheses, it will jump to the first one. You can easily go from the first to the ending one, and go from the ending one back to the beginning one. Right, so let's go ahead and check this out. Check this out. G++ dash O comma. I'm just being lazy here. Yep, it is 5. All right. So the comma separated listing is really, as you said, it's kind of like the open curly brace and the closed curly brace. It allows you to combine multiple expressions into one expression, which is one way to make your program exceedingly difficult to read. All right, so are there any additional questions about this one? forgot about this one. Let's go on to the last one. The last one is the only one that let you exercise your creativity a little bit. So this one gives you some assumptions. Assume that you are given several initialized variables as follows. B is the beginning value of something, and this is guaranteed to be a non-negative integer, and it's at least 2. So it starts with a value of 2. E is an AND value. This is an integer guaranteed to be larger than B, so it's at least 3 and up, basically. F is a factor. This is an integer that is guaranteed to be at least 2, and counter is just a regular counter. It is initialized to 0. You are also given an uninitialized variable x. Write the code to count using the counter to count the number of integers between b and e inclusively that are multiples of f or divisible by f. Okay? There's no need to declare any of the mentioned variables. Assume they're all declared. You may also assume the initialization is already done for the initialized ones. So your code only has to specify whatever logic is needed in order to find out the number of multiples of f between b and e inclusively. All right? So how do we do that? Now, some people may think, oh, we can mathematically do that, right? So we'll start with e minus b, that will give us a range of numbers, and divide it by f. So that will tell us how many multiples of f can fit in between. But that won't give you an exact answer, okay? Because it is possible that I give you a range where f is there. The range can be like just 2 numbers, and the multiple f just so happens to fall into that category. So what I would do is just to do it the long way, use a loop and count, right? I mean, that's really the easiest way to do it. The whole purpose of x as an uninitialized variable at this point is so that you can use x to focus on, okay, which number am I processing within this iteration? Okay, so you have to use a loop to do it. Now, for those of you who are kind of new to programming, well, we have all taken CISP 300 and 301 before, so we have some exposure to writing programs. But you can always use, like an example to help you understand, okay, what do I need to do in this case? What do we need? Okay, so I'm not telling you exactly what B is or what E is. I'm just telling you that they are non-negative. B is at least 2, E is larger than B, is also an integer. That's all I'm telling you. So you can't really just use a conditional statement to do it. What do you need in order to get this logic done? A for loop. Okay? So let's start with a for loop. Alright, so this is a for loop here. We are using counter to count the number of multiples of f, but it's already initialized to 0. Okay? If you want to double check and make sure it is all initialized, this won't be an error, okay? Because I did not say that you cannot double initialize something that is already initialized. So it's already 0, you can reinitialize to 0. But since it's not necessary, we'll take it away. But there is one variable that you are told that is uninitialized. So maybe you should deal with that one, right? That's a hint, right? It's uninitialized. It is up to you to do something about it. So what should we initialize x with? It is the value that we are processing for each iteration. And where do we start? I mean, you can start with E if you want to and then do a decrement back to B. But most people do it the other way around. You start with B and then increment to E, okay? So we'll start with B here, okay? We start, B is the first number that we are processing. And when do we stay in the loop, okay? Remember, it's inclusive. We want to process the number b itself all the way up to the number e itself. So if x is the number that is going up from b to e, when should I stay in the loop? Okay, as long as x is less than or equal to is correct. Okay, because we need to include a case where x equals to e. That is the last one that we have to process. Is that making any sense? because I did say inclusively, so that means E is a number that I need to process. What do we do as a post operation? Nope, not increment counter.
Add 1 to X.
Yep, add 1 to X. So I'll just use a pre-increment X here. And what do I do for each iteration? Okay, so for each iteration, we're basically saying, okay, instead of focusing the entire range from B to E inclusively, now I have a single number X to look at and say, okay, is X a multiple of F? If so, increment the counter. That's what we need to do. I think I just answered my own question, right? What type of control structure do we need? If conditional statement, right? All right, so here's the template of a conditional statement. Now, I have all the parts here. If I decide not to use it later, hey, that's okay. What condition are we looking for here?
X is equal to B times Y. I mean B times Z.
Equals to E minus F.
Sorry?
Oh, okay.
E minus F.
If X is
You got the right You got the right operator, and you got the right variable. X mod with F, and what about it? Okay, let's write it down first, and then we'll decide what to do with it. Okay, what do we do with this?
It's divisible by 2, the mod should be 0, right?
If it is divisible, the remainder will be 0. Correct. Now, at this point, we have a choice. Okay, we actually have a choice here. You can just leave it the way it is, and then specify only do something about else. What? Okay, let me write it here, and then I'll explain it. It will accomplish what we wanted to do. Why? I mean, how? It doesn't make any sense. This doesn't even look like a condition to me. Well, let me ask you this question then. Does it give you a number?
Yes.
Is that number a 0 or a non-zero? Well, anything that can be either a 0 or non-zero can be considered as a condition in C and C++. Okay, well, but in this case, when is it going to give me a 0 in this case? When X is a multiple of F, right? Which means X is divisible by F. Okay, when X is divisible by F, it returns a 0. Okay? But what does 0 mean as a condition of a conditional statement?
False.
It means false. So if the condition of a conditional statement is false, which branch should I follow?
Else.
Else branch. And what am I doing with the else branch?
So that's what you want to do.
Exactly. So it works this way too. Okay, it's counterintuitive, right? Because it doesn't even look like a condition. I'm not comparing it to anything. I'm just using the remainder of a calculation. But as it turns out, in this particular case, when the remainder is 0, that is exactly when I want to do something about it. When it is non-zero, I don't want to do anything about it. That's why the then branch is empty. There's nothing to do. Okay, but it is counterintuitive. Now, for those of you who like something that is more intuitive, it makes more sense to write this code in this form, which says when this is 0, increment the counter. For all other cases, don't do a single thing. These two versions of the code would do exactly the same thing. Okay, if you compare this version to this version here, they are functionally equivalent. Are there any questions about this? Questions about this? Is this the only way to implement this logic?
Probably not.
Well, let's boil this down to the most basic stuff and still call it a structured program, okay? So what we can also do is to say x equals b is happening before the loop, but this time instead of a for loop, I use a while loop. Now, when you convert a for loop into a while loop, it's easy, okay? Because every piece has a place to go. The initialization goes before the loop itself. the condition stays at the same place as the condition of the loop. Inside, whatever we used to do here, we still have to do it. So we copy and paste the entire conditional statement, stash it here, and then whatever the post operation specifies, we do it after that. So that becomes the last operation to perform. So that would be the same code. It is functionally equivalent to the one before that. Is that okay? I just want to show you different ways of implementing exactly the same logic here. Well, is this the only way to do it? Can I get away without using a conditional statement? Is there an expression that can sort of do what a conditional statement can do? The ternary operator. Okay, so let's see. Can we use a ternary operator here? X equals b, and we'll keep the rest the same, okay? And we'll say, can we use a ternary operator here? Okay, well, okay, if we use a ternary operator, that means we have at least these components to talk about. And we have to do something about this, right? I mean, so that means, we are probably expecting to use an assignment operation to affect counter, right? But counter, I don't want to reset it to a particular value. I want it to count up, right? So that means, we will specify a plus equal here. Sometimes we wanted to add 1, other times we wanted to add 0. So when do we want to specify a 1 and when do we want to specify a 0 here? This is corresponding to this expression being true. This is corresponding to when the expression is false. So that would be x% f equals to 0. If x mod f is 0, which means x is a multiple of f, we return a 1, so the counter is incremented. If x mod f does not return a 0, that means x is not a multiple of f, then we want to return a value of 0, which means we're adding 0 to counter. Counter keeps its old value. And we still need the other one, plus x here. Okay, because otherwise it will be processing the same number over and over and over again. But there's another way to simplify this. I can take this out and put it here. So I would use the value of x before the increment to do all the decision making and whatnot, and then do the increment after. So that's why the post increment operator is quote unquote useful in C and C++, because it let me write cryptic programs like this. I mean, you have to admit this is kind of cryptic. I mean, this is, but it works.
Yeah, I know, right?
That's according to Wally from Dilbert. This is one way to guarantee job security. Because your boss may fire you, but then within a month, he will hire you back.
How do you do this?
Because when you come back, you look around and go like, wow, 80% of the employees are having migraine. I wonder why. Well, I showed your code to all your colleagues and they all end up with migraine, and so we want you back. Yeah, this is the kind of code that can cause that to happen. Yeah, which is not necessarily a good thing. Yeah.
Double my pay.
Huh?
Double my pay.
Double your pay. Oh, Wally has other ways to make money too. There was one strip, one episode where the boss, the pointy hair guy, said, if you catch a bug, I'll pay you X amount of money. Do you guys remember? Do you guys watch Dilbert? No. Okay. So there was one storyline like that. The pointy hair boss said, I'm gonna encourage people to fix bugs. So for every bug that you catch, I'll pay you X amount of money. And then as Wally walked away from the meeting, he talked to himself and said, I'm gonna write myself a minivan. Does everybody understand what he meant by that? he'll intentionally write buggy programs and then catch the bugs later on to make more money. So he said, I will write myself a minivan. Yep.
Do you have another version of the Mach 4 question?
The what? Which one?
Like
again?
this question we're working on another version of it.
Oh,
since
okay.
We kind of went through it already,
Right.
another one that we could work on.
Another student from the other class also asked the same thing, so I'm going to work on a few, sample program. I will ask you to do something, and
Okay.
then I will have you guys to kind of work on it.
Because the other ones I think I can recycle or work on them and it'd be fine. But this one, I'm not sure. Another question would be good.
Right. Okay. Yeah, I'll give you maybe 2 more, and then we can talk about it on Wednesday. On Wednesday. Yep.
So all those are correct answers, right?
All of these are correct answers. They all do the same thing, even though some are obvious and some are not so obvious, but they all in the end do the same thing. That's kind of what you can do with C and C++, the syntax allows you to do the same thing, but using many different ways. And the most important point is we have talked about all of this stuff already. So even though we are only, 7 weeks into the semester, and we have only talked about control structure and expressions, there's already a lot of stuff that can be done. Programming is like playing with Legos, okay? So when you look at all the blocks of Legos, each one doesn't seem like, this is just a 2x4 piece, this is a 2x2 piece, this is a stud. No big deal, right? Each piece is nothing. But when you think of all the possible ways of connecting the pieces, that's where things happen, right? But Lego pieces cannot nest. Okay? And statements in C and C++ and expressions, they can nest. You can have one as a component of the other one, and that opens up all the possibilities. Okay? I cannot possibly enumerate all the ways to combine all the different things that we have already talked about. Even that is already a lot of stuff. So I'm only demonstrating the more kind of obvious ones. I go step by step and say, okay, from here we can go here. From here we can go here. So you kind of have to look at each step and understand why the second form is equivalent to the first one. Why they don't look exactly the same, so how come it will still work the same way? Okay. Any questions at this point? We still have about 3 more minutes, so this will be a good time to kind of ask some questions. And so you can see the test is not about memorizations. Okay, you can print out, go to the C++ reference website and print out whatever you want to print out and bring in a big pile of paper. The more you print, the less likely you can find what you need to find. Okay? So what you need to do is to kind of dig through all that stuff, study a little bit, relate to what we have talked about in class, and come up with your own cheat sheet. It's not cheating anyway, because I do allow any number of pages or books or whatever you want to bring in. But that's how you study for this class, is to understand the concept. And the most important part is to understand how one component can plug into another component. That really is the key. It's not that one thing by itself, but how can we use this in a different context? How do these components, how are they interchangeable? How can they plug into each other? That really is the key to study for this class. Is that okay? Oh, well, it's too late for that. I don't think we can take row in 1 minute and a half. Is that why you guys are still staying here? Yep.
How many questions are going to be on the exam?
I would say, maybe 4 or 5, questions, of this type, would be only 4 to
Like
5.
this, just like what you have here. Okay.
Right.
Sweet.
I might have questions just what I've gone
Okay,
over.
let me turn off the
All right.
recorder first, unless you want to be recorded.
Oh, no, that's okay.